All right, so thanks everyone for joining America Summit today. What we'll be talking about is analytics at scale at Intuit with cloud native tools. So Neil Colley here, I'm a senior worldwide go-to-market analytics lead, and Denise McInerney, a data engineering leader at Intuit, will be bringing you the presentation. All right, so from an introduction perspective, Denise has been working with data since 1996. She's had a variety of roles, everything from DBA to analyst, and of course, she's a data engineering leader today at Intuit. She's also a strong advocate for women in technology and also a part of our AWS community builder. Now, from an agenda perspective today, what we'll be covering is Intuit's data environment, analytics pre-AWS, migration modernization, as well as technical challenges and some of the paradigm shifts as part of that. So Denise, over to you. Thank you.
Thank you for that introduction, Neil, and thank all of you for coming to this session today. Today I'm going to describe to you Intuit's journey with our analytics solutions to the AWS cloud. In order to do that, I'll describe a little bit about our data environment, what we were doing with analytics prior to moving to AWS. Then I'll spend most of my time talking about how we've migrated and modernized our analytics stack. In doing that, I'll share some of the technical challenge we faced and how we addressed them, and also talk about the paradigm shifts that we had to make in order to be successful in this journey. Now, for those of you who may not be familiar, Intuit is a company that provides software and services, both for consumers and small businesses and the self-employed. Some of our flagship products you may have heard of are TurboTax and QuickBooks. Now, the company has been around since the early 1980s. We moved from being we started as a desktop company, of course, back in those days. That's what everyone was doing. We moved to being a SaaS-based company where all of our services offered online. And now we are really a platform company with an emphasis on AI-driven products and services to help our customers. Now, as we've made that journey throughout the evolution of software, we've also seen increasing potential for using data to better serve our customers and provide them with better products. Our data story mirrored our sort of general software story, right? So in the beginning, we had siloed, sort of purpose-built analytics and BI type solutions. They were built on a variety of tech stacks. Eventually, as we moved to wanting to centralize our data, we invested in an MPP appliance. But this was all in our on-premise data center, of course. We invested in MPP appliance. And that was really the first attempt we had to bring all of our data together. It was a pretty uneven experience. For one thing, we couldn't bring all of our data together, so it was a subset. So there was always gaps in what users could find in that place. And also we had some performance issues. We were really learning our way into this space, as so many people did, so many groups were. So we definitely had some performance issues. Around about the same time, Hadoop became a bigger deal. It hadn't, we think about Hadoop as being around for a long time. But it was less than 15 years ago, right? So we then began to build a Hadoop data lake in our on-premise data center. And this was really the first time we brought all of the data together in one location. And so that was a positive, and users liked that. However, their experience doing sort of interactive queries in that environment was not great. And it was quite different from the MPP from that perspective. Back in those days, basically the only query tool we had for them was Hive, and that is not a particularly satisfying interactive query experience. So we were then on to the next phase of this journey, and we adopted a new MPP. And this, the architecture of this MPP allowed us to scale out more and have more data there. And it was faster performance from an interactive query perspective. However, it brought us another set of challenges. We had redundant data, so we had data in our Hadoop data lake and data in the MPP. And we started adopting the MPP more and more for processing, which is really not its sweet spot, but that was due to the performance challenges we had in the lake. So I would say that we really misuse this MPP in many ways, treating it as a quasi-data lake, treating it as an ETL platform, as well as treating it as an analytics platform. And what we saw was the competing workloads on the MPP really surfaced a lot of challenges for us and for our users in terms of scale and user experience. So at this point, after several years now and getting to this point, it was really time to take the next step, and it was time to move our analytics story into the cloud. Now, Intuit as a company had already moved all of our products and services to AWS, actually. So we had been serving up our products from the AWS cloud for a period of time prior to analytics taking this step. Analytics was really the last piece, right? So the first step to get out of our on-prem center to AWS was effectively a lift and shift, right? With a few changes, right? So we used S3 as the storage layer for the data lake instead of Hadoop. But we took that same MPP that we had been hosting internally and hosted it on EC2 instances in AWS. So there was a few improvements from an engineer perspective. There were some new tools they could start to use, right? These cloud tools that they'd heard so much about, they could now begin to actually get familiar with and maybe use for some cases. But from a user perspective, there really was no change. We were still running the same MPP with the same anti-patterns of using it for raw data storage, ETL processing, and analytics. So we hadn't really moved the needle in improvement there. But by doing this lift and shift and getting everything out of our data center, we were now positioned to modernize the analytics platform and really take advantage of what the cloud has to offer in terms of scale and elasticity. So this is what the picture looked like after the lift and shift, right? So you read this left to right. Our source data on the left moves into our data lake. Now, I want to point out one aspect of our data lake, which is that Hive Metastore. That is something that came over from the on-prem data lake. We were using the Hive and continue to use the Hive Metastore as the metadata repository. The MPP was doing all of the ETL, or most of the ETL, as I mentioned. We had used Hive on the on-prem story, so we continued to use Hive for querying via Amazon EMR, but the users were primarily focused on the MPP. So this was a very similar data flow pattern from what we did on-prem. Right, so the lift and shift is complete. Now, what are our objectives for this modernization journey? We wanted to leverage the data lake for exploration, right? So all of that raw data on the MPP that users were exploring through, we wanted to do that via the lake. We wanted to move the processing, the ETL processing, off of the MPP, effectively a shift left, right, closer to the source data. I mentioned we had a lot of data redundancy because we had 2 copies of things in the lake and in the MPP. We wanted to eliminate that if possible, but certainly minimize it. And really, we wanted to use the right tool for the job, right? So I mentioned that we were using the MPP for multiple workloads, multiple access patterns. It wasn't the right tool for all of those. So now we had a choice. We had a toolbox. When you look into all the analytics services available through AWS, we had a number of tools. We wanted to make sure we were leveraging the right ones for the right use cases. And finally, we wanted to adopt Amazon Redshift as our data warehouse MPP platform, but we wanted to use it in the right way, not misuse it as we had with its predecessor. So those were the objectives. And once those objectives were met, this is what the data flow looks like. Again, source data left to right. The Hive Metastore doesn't go away. It's still there, and that will come up again as I describe the details of our journey. But now for ETL, we're looking at Amazon EMR, AWS Glue. And for querying, Amazon Athena for the data lake exploration, and then Amazon Redshift for the appropriate workloads there. So this is what it looks like when we're done with this journey. So let's look at each of these objectives and tell you a little bit more about our experience getting there. First is leveraging the data lake for exploration. So the MPP from a user perspective was still the primary platform. And we couldn't scale it out anymore, and we didn't want to scale it out anymore by bringing more raw data there. We wanted the analysts to use the lake for exploration, but their experience on Hive had been pretty poor. That's where Amazon Athena comes in, right? Amazon Athena is a fantastic service made for interactive querying of S3, right? It's very quick, it's very fast, it's very familiar to the users. From an engineering and infrastructure perspective, it's serverless, so less for us to manage. However, we couldn't just adopt it right away. And this is where the Hive Metastore comes in the first time, because when we first started on this journey, Athena was not integrated with the Hive Metastore at all. And we tried a number of workarounds. So Amazon Athena at that time only integrated with AWS Glue for metadata. So we tried a number of workarounds, syncing back and forth, copying, and they just did not scale. Our metadata repo was too big and just was not going to scale out the way we needed it to. But we worked very closely with AWS on the feature which is now available to everyone, which is integration with the Hive Metastore. And this was a very big deal for us because this really positioned us to be able to adopt Amazon Athena the way we wanted to and to use it for a purpose that we really needed fulfilled, which is many users being able to munge through a lot of data stored in S3. So the Hive Metastore feature was the first thing that really enabled us to adopt Athena at scale. Now, we still had the same MPP, yeah? And there's a very common use case where users needed to join raw data, which we now were focusing on storing in S3 in the lake, with process data, which appropriately was stored on the MPP. So that need to join. And satisfying that use case was also going to be a big deal in terms of adopting or meeting our objective of using the lake for exploration. So the solution we went to here was the Athena Federated Query feature. Now, this was a feature announced after we adopted Athena. However, when that feature first became available, it did not have a connector for our particular MPP. So we needed a way to connect to our MPP in order to use this federated query capability. Again, we collaborated very closely with our partners at AWS because this federated query feature does come with an SDK, so it's possible to develop other connectors, and that is what we did with our partners at AWS. And so from a user perspective, they were just issuing the same queries effectively, but behind the scenes, it was querying our MPP. So I have a snippet of pseudocode on the slide, which shows you effectively they're just calling a Lambda function, and they're qualifying, further qualifying the name of the table in the MPP with the use of that Lambda function. But otherwise, the SQL is the same. And this was something that once we adopted it, again, became very popular with our users and really enabled more use cases to be solved with Athena. Now, if you're interested in this particular capability, this particular feature, we do have a blog post out there with our partners at AWS we collaborated with. And so I've included that link in the slides as well. And I'd encourage you to read that blog post to see more about how we implemented this connector. And this is a simple view of the architecture. So again, from a user perspective, they're issuing a query to Athena with that same syntax that I shared. Athena is cleverly knowing which part of that query goes directly to the data lake in S3 and which goes through the Lambda to query the MPP. The data comes back to Athena and the joins are done and presented to the user as the same kind of result set. So very smooth, very elegant from a user perspective. And we got really good performance out of this as well. So we've been really pleased with this capability, and our users it's been very popular with our users also. All right. Now, everything wasn't all sunshine and roses because leveraging the data lake for exploration was quite different from the MPP in a couple of ways. The first was performance, or I should say tuning, right? So every data platform has its own approach to tuning, and you need to become adept at that to get the best out of that platform. But this MPP, we'd scaled it out pretty big, and so it was quite forgiving, maybe of not well-tuned tables or not well-written queries. The data lake was less forgiving of all of that. So we really needed to spend time educating ourselves and our users on how to write queries that would be efficient. The other thing we ran into, and this was a decision we made that we then sort of adjusted, which is there had been a lot of concerns about the cost of Athena potentially because it is a cost model that's based on amount of data scanned. So we set very conservative restrictions. You can set limits on it, and we set very conservative limits initially. And our analysts just kept running into, hey, you can't run this query because you've exceeded the scan limits. So these were two things and they go together, by the way. These are two things we really had to address in order to get the most out of this. So the first on the query performance. When we're talking about S3, this all comes down to the partitions, how the data is partitioned, how the data is prepared for the users to consume, and then education, so the users understand how to leverage these partitions in order to get the most efficient queries. So partitions has been a big topic of education for us. Now, of course, the more efficient your queries, the less data you're scanning. So that addresses one of the concerns around cost and governance. But we also recognize that our initial limits were set really unreasonably low. And so the way we got to the right number was we took some of our largest data sets. Our clickstream would be one of those, as an example, pretty common for that to be quite large. And we ran queries, we took the limits off, we ran queries that would be reasonable for analysts to actually run. And we looked at how much data would be scanned in, when they're well-written queries, and we changed the limits to match that. And that eliminated that problem. And frankly, cost has not been an issue thus far. We keep an eye on it, of course, we monitor it, but the use of Athena with large queries has still been a perfectly reasonable cost for us. So definitely some knobs you can turn if you're using Athena, but that was our experience with it. So I've talked about the users a lot, sort of as objects to what I'm describing. But really getting here and adopting all these new tools and learning these new platforms, you have to partner with your users for that to be successful and effective. We were driving a lot of change. And of course, they're going to gravitate to what's familiar to them, right? So the MPP had been the main platform, and that was what they were familiar with. And also, as my earlier slides described, we put them through a number of migrations. Some folks had been with us through all of those. Some were newer and maybe only been through part of it, but nonetheless, there was a certain amount of fatigue there. And from their perspective, on the one hand, everything was working fine, right? Of course, it really wasn't, right? Because this MPP was hitting the law of diminishing returns. We couldn't scale it out much more and really see significant improvement in performance. The resource contention issue just kept getting worse and worse because the mixed workloads kept increasing. And there would be more and more delays to delivering data, none of which was a great user experience, right? So, but we had to ensure that what we were delivering next would improve on all those things, right? And so it's a combination of really partnering, explaining what your vision is, demonstrating how it works, making sure they have the training to know how to use the new tools, and listening to their feedback and their concerns so that you can address them. The scan limits would have been a simple example of that, right? When they came back to us and said, hey, this isn't working. So all of this, driving all this technical change and also enabling the users to take advantage of it, those two things really went hand in hand for us. All right, so all of that was about the objective of using the data lake for exploration. Now I want to talk a little bit about shifting the data processing left. So the first place we started here was with adoption of Amazon EMR. This is pretty natural, right? We'd already been doing some Spark processing in the on-prem data center. EMR is analogous to that. It was easy for engineers to sort of understand that paradigm. And of course, Spark is really, core to data processing workloads. So we started there. And we really used some opportunistic adoption approaches, right? A new project, maybe, or something small, so we could learn our way into it. We didn't want to bite off more than we could chew, right? And not be successful. So it was baby steps at first, but over time, now EMR is key to most of our data processing, certainly all of our batch data processing. But initially, we tried to be smart about how we did it. And there was lots to learn, right? Spark is non-trivial. Lots of knobs to turn, lots of parameters to adjust. And so we wanted to make sure the engineers had time to learn their way into that. Of course, the bigger the data set, the more important this is. So that was a big piece of the learning. Another part of it was right-sizing the clusters, right? Because there's a lot of variables to EMR node type and cluster size. And for both of these things, both the Spark tuning and right-sizing the clusters, we really partnered with AWS. They have been a big help to us in figuring out how to get to that sweet spot while still managing cost, right? You can have giant clusters, but if you're not effectively using them, then you're paying for hardware you don't need. So it's really a balance of all of those things together. And as I said, the team has, as a whole, gotten much more adept at this, and we're pretty happy with how we've done in terms of migrating a lot of that MPP ETL processing to Spark. Now, of course, EMR is not the only service that allows you to do ETL in AWS. And so AWS Glue was another service that we started looking into it when we first started the migration. But it was much more of an exploratory phase because this was very new territory. And we wanted to really understand how we could integrate it with our environment. We have a pretty complex environment. We have some things that are sort of non-standard or very Intuit specific. And so not every AWS service just works for us out of the box. We have to make some adjustments. And so we started again opportunistically with the kinds of projects where it made sense and we could use it effectively. Early, it was some file cleanup, file concatenation type stuff that we could do out of the box with Glue. The third-party custom connectors, we ingest a lot of data from external sources, and we have found that to be very successful. So we started with one, but we've now built out more custom connectors, and that's become a key part of our architecture as well. But we did have a lot of challenges, integration challenges with our environment. We have an internal security service that we really had to work with the AWS team to, and a couple of engineers on our team really dug into this to understand how it would work, and collaborated closely, I would say, with the AWS Glue service team to enable this to happen. That Hive Metastore, again, rears its ugly head again. So the Hive Metastore was another challenge, integration with that from a Glue perspective. There were some file types we were using that didn't work right away. And so once all of those things were resolved, and that was a really, as I said, collaboration with AWS, the Glue team turning out some new features for us, helping us brainstorm solutions. Once we could do all of that, then we were in a position to integrate AWS Glue in a serious way with some of our internal frameworks, which was another goal we had. And that was recently accomplished as well. So we've made a lot of progress in leveraging AWS Glue in the time we've been on this journey. So we're also quite happy with that. Now, shifting left also is a mindset shift, right? So thinking about things differently, which is a lot of that's really an underlying theme of this whole talk, right? Is we were thinking about things differently. The first thing, which seems obvious, but is worth saying, is S3 is not a database. And if you've been doing everything in an MPP kind of environment, a more database-centric kind of environment, it takes some mindset changes to really understand how to do what you want to do on in a file system. So things that might be straightforward, an update type thing, upsert type behaviors in a database, you have to think about differently. And a lot of that was about understanding the data, right? Understanding the mutability, understanding the size, understanding the access patterns, so that as we're moving these workloads off of the MPP to S3 and to Spark, we could really plan to do it efficiently. And in many cases, the design of the pipeline had to change, right? And that would make sense because the paradigm is quite different. And so again, the partitioning, I talked about partitioning when I talked about the data lake exploration. So this is another area where you have to think about this, because the partitioning that makes your ETL workloads run faster may not be the right partitioning strategy for your data access patterns, right, for your querying. And so thinking about how to balance those, sometimes it means repartitioning again for data consumption. I mean, you just have to be really open to understand how to make this data effective, especially with your largest data sets. And those are the ones we're really focused on, obviously, because the queries on those could be quite slow and quite expensive. So it's all a balance. Nothing comes for free. And we've learned a lot about the nuances of that as we've gone through this journey as well. And that's just experience, right? You just have to use the tools and see what happens and gain the experience to be able to make those judgment calls as you go forward. Now, most of what I just talked about was really about the data engineers making those shifts. The analysts also had to make a shift left, right? So analysts have their own pipelines. Analysts manage pipelines for various reasons. Sometimes they're doing experimentation, sometimes they just need something temporarily, sometimes a number of reasons, but they had a lot of pipelines, and they had written them all to run on the MPP. And so this was a big change. And obviously we wanted to get off that MPP reliance. So initially, our initial plan was, well, we'll use Spark for this because Spark is a data processing engine, and that's what we're using for all the other ETL. And a couple of members of the team actually wrote a utility to convert those MPP, the SQL scripts written for the MPP, to Spark SQL, so that would be at least a basis for them the analysts to move their jobs. This did not really go as planned. because the Spark environment was just very alien, very unfamiliar. And the same things that engineers might, really dig into in terms of tuning was like a whole nother area that the analysts did not have familiarity with, right? And so it was a pretty bumpy road. Not going to lie about that. And that whole path for them from development to testing to production, there was just too many points of friction, and it just wasn't, the velocity wasn't there for them, and the experience was poor. It was the user experience was not good. So this was an area where we really sort of struggled and had to have some conversations to understand their workflow, the analyst workflows, understand what they were looking for, and then how we could provide it to them. Now, one of the bright spots I mentioned earlier was Amazon Athena, and the analysts really gravitated to it. The performance was good, the environment was familiar. So we tried to think about how we could leverage that better, right, when we're talking about these analyst-owned pipelines. And so what we decided to do was add the ability to run Presto jobs in our production tools. So you probably know this, but Amazon Athena is based on Presto. So the syntax is the same. There were a number of internal reasons why we couldn't just run production jobs on Athena, but we could offer an environment where the analysts could develop their code in Athena, test it there, and then productionize the job using Presto. And we added Presto to some internal tools we have for pipelining. And that's very promising. That's a pretty recent development, but we're pretty excited about how that's looking. And again, it removed a lot of friction points for the end users. And that was really our goal there, while still delivering on something that we could support in production that was consistent with the rest of the architecture. Again, the right tool for the job, right? Analyst pipelines are not really the same as engineering pipelines often in terms of the amount of data, or what they're doing, the complexity, the number of steps. So using Presto for this is actually appropriate for a lot of the types of workloads that they have. So this is all part of their shift left experience as well. All right, so the last objective we had in this whole journey was using Redshift, but using it in the right way. So obviously, Redshift is a very versatile tool as well. You could do a lot of things with it, but we were really conscious about not wanting to misuse it the way we had misused its predecessor. And so for us, we decided that where Redshift fits is for a certain type of access pattern and a certain type of data. And here I'm talking about Redshift native storage, right? And so it is effectively our data warehouse platform, and that means it's hosting facts, dimensions, and aggregate tables, right? Which is the classic sort of definition of a data warehouse. These are the data sources for our executive-facing reports, for our dashboards, things that have to be frequently accessed by a lot of users or by a lot of dashboards, where we need really snappy performance or really snappy interactive analytical type queries. There's no doubt that Redshift's the right tool for that job. And so that is really how we're leveraging it and how we're leaning into it. Now, there's some other things that you get when you use Redshift with other AWS services that are really great, right? And the first one of those is Amazon Redshift Spectrum. And so Spectrum is the tool that allows you to join data that's stored in Redshift native storage with data stored in S3. And if you think back to that use case example I had where raw data stored joined with process data was a common use case, Redshift Spectrum solves this for us really well. And you don't have to have two copies of the data again. So this has been, another service that has been big adoption. Users really like it. Redshift's familiar. They're doing other work in Redshift. So now if they need data from the data lake, they can just use Redshift also to access that, to join it with the existing data. Really happy about that. The other feature that is fairly recent is this Amazon Redshift data sharing. Now, in our environment, we have 8 or 9 Redshift clusters that the analysts need access to for different purposes, different domains, different kinds of data hosted on each. But there are often use cases where they'll need to join data that may be hosted on 2 different clusters. And again, we're talking about like 2 different data marts that they need to bring together for some aggregate. What data sharing allows us to do is enables joining between 2 Redshift clusters without moving the data. So we don't have to make a copy of the data. We don't have to have more data redundancy, which we're trying to avoid. And again, that familiar environment where they can join the data sets together across the 2 clusters. We're very bullish about what this is going to mean for us because we did do a lot of copying data back and forth in the old days. Now, one thing to keep in mind about data sharing is it's enabled by the certain node type, the RA3 node type. So we had clusters built on different node types, and so we had to make sure that we moved everything to that node type so that we can enable this for all of the use cases. So that's just something, if this is a feature you're interested in, that's just something to keep in mind. And again, our partners at AWS worked with us to right size those clusters as well, right? To make sure we're doing the right conversion between the other node types in RA3 in order to get the performance and cost balance that we were looking for. So all of this together puts us in a position to really leverage Redshift in the way that it's going to best meet our needs in our environment, while still allowing us to use the other tools for the use cases that are appropriate. So just to recap, the objectives we had and the benefits we got by achieving those objectives. That data lake for exploration meant less delays in moving data around, more analysis. Analysts could actually do more analysis. Moving that processing left gave us more scale, gave us more elasticity, gave our developers more tools, more appropriate tools for doing certain kinds of data processing. It meant the data has been available sooner. That continues to be true. And it eliminates that resource contention on the MPP, which was just such a big hindrance for us. You eliminate the resource contention, you free up the analyst productivity, right? They're not waiting for the MPP to become available. It's available, right? The data lake is available all the time. And so that is another real advance in terms of unleashing their productivity. And that Redshift migration, that last piece, gave us the flexibility and the elasticity of using a managed service for our data warehouse platform and all of the native integrations with S3, with the other Redshift clusters. And so that has really set us up to leverage all these tools in the best way possible and modernize our whole analytics story. So thank you very much for your time and your attention today. There are lots of resources out there for learning more about AWS Analytics Services. Here are some of the trainings and certifications available to you. And I'd encourage anyone who's moving into this space or whose team is on a similar journey to take advantage of these training resources. And with that, I'd like to thank you for sharing your time with me today. Hopefully you found this session useful. Thank you so much.